Welcome to Mathematics with Suleiman, and I'm starting with the paper 2 of Gauteng Prelim 2025. And this video, I'm going to do question 1 on statistics. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Preparatory Examination 2025, Paper 2, Question 1. Question 1. The histogram below shows the marks in percentages of grade 11 learners in their November 2024 examination. Now, have a good look at the histogram. The horizontal axis shows the marks in percentage, and of course the vertical axis shows the number of learners. Let's have a good look at the histogram before we look at the questions in the next section. Thus, in question 1.1, the table was given and you had to complete this frequency or cumulative frequency table. Now, if you go to your histogram, you will see that between the intervals 10 to 20, we have a frequency of 2. Between 20 and 30, a 3. 30 and 40, a 4. 40 and 50, a 6. 50 and 60, a 5. 60 and 70, a 4. 70 and 80, a 6. So all that info comes from the histogram. Now, how do we complete the cumulative frequency? Have a look at the first between 10 and 20. Frequency 2, cumulative frequency also 2. Right. Then the next one, remember, frequency was 3. Now, how do we get the 5? We add the 3 and the 2. And 3 plus 2 gives you 5. How do we get the 9? We say 5 plus 4 is 9. How do we get 15? 9 plus 6 is 15. How do we get 20? 15 plus 5 is 20. How do we get 24? 20 plus 4 is 24. How do we get 30? 24 plus 6. So I hope you followed my argument. How could we complete the cumulative frequency column? 1.2, draw an ogive, or another word, cumulative frequency graph to represent the data. Now, where do we start? Remember, this is very important. Your first point must be on the x-axis, right? And how do we know which point? So look at the red circle and the red line. So whatever is there by 10, so that 10 will then go where the red arrow is. Now that is clear. So it's 10 and 0, right? Then the next point, look at the 20 in green. So the 20 in green is linked to the 2 in the cumulative frequency. So that 20 goes with 2. And that's how I can go on. Then the next point will be a 30. That 30 will go with 5. Right? The 40 will go with 9. The 50 goes with 15. The 60 goes with 20. The 70 goes with 24. And then I showed the 80 again with using the blue line. So the 80 goes with 30. So please practice this until you get it right. Very important. Open 1.3, use the ogive to estimate how many learners obtain at least 54% in the examination. So look at the dotted line. So you go to 54 on the horizontal axis, move up vertically until you touch the graph, then move across horizontally, and then the answer is 17 learners obtained 54%. Question 1.4, it is further given that the minimum mark is 12%. So now they tell you what is the minimum mark is 12%, and the range of the data is 66%. Right. So to draw a box and whisker diagram, you know you need maximum value, you need minimum value, you need lower quartile, you need median, and you need upper quartile. So again, people, go and do your research. You've done it in grade 10 and 11 if you have forgotten. So the minimum will be the 12, right? And of course, the upper quartile is 37. The median is 50 as shown on the box and whisker, and the upper quartile is 67. Right, so how do I get the 78? Remember they said that the range is 66%. So from 12 to 66 will give you 78. Okay.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Welcome to Mathematics with Suleiman, and I'm currently discussing paper 2, the Gauteng Prelim of 2025, and I'm doing today paper 2, question 2 on statistics. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Gauteng Province Preparatory Examination 2025, Paper 2, Question 2. Question 2.1. A town manager conducted a survey to measure the pressure of the sea level in his coastal city. The table in the scatter plot below shows the results of the survey. Now have a good look at the table. They give you the depth of the sea levels in feet. FT stands for feet. That's the old British system. And the pressure is in kilopascal. And now, of course, below that is your scatter plot. So all the information is then depicted on the scatter plot. So have a good look at the scatter plot. Look at the characteristics of the scatter plot. Right, so question 2.11. Determine the equation of the least square regression line for the data. Now you remember the formula for the least square regression line will be that equation there given with y with a little toppy on top of it equals to a plus bx. Right, and of course that is now where the slope, that is b, where slope, people, you remember, is also gradient because that formula is actually a straight line. Now, of course, you don't have to know these formulas anymore because you can do it on the calculator. If you don't know how to do it, please ask your teacher to show you how to use a calculator and to find the values of small letter a and small letter b. Or you can use the link I've given you down there to access one of my videos explaining how to use a calculator. Or of course, you can also use AI platforms like ChatGPT to explain to you how to use a calculator to find the least square regression line. However, once you've done that, then the answers will be small letter A is 55.96, small letter B is 22.81, so therefore the answer will then be y equals to 55.96 plus 22.81 x. 2.12. Use the scatter plot provided above to draw the least square regression line. So you got a formula now from the previous equation, from the previous question, I mean. So then plot it like you will plot any other straight line graph. Then you must at least have 2 points correct, right? And then you can just draw your straight line. And of course, to find the 0.13, to write down the correlation coefficient, that can also be done on the calculator. 2.2, research was conducted to measure the testosterone levels in runners at the Olympic Games. The table below shows the results of 5 runners who who were tested for testosterone. Of course, people, testosterone is a male hormone. Look at the runners. There's runner 1, 2, 3, 4, 5, and the levels are given as for the runner 1, 6,7, for runner 2 is 2K plus 2.4, for runner 3 is P, for runner 4 is 3.8, and for runner 5 is 4.3. Now the mean of the 5 runners is 7,7, and the values of the last 3 runners form an arithmetic sequence. Very important. The last 3 runners, that is runners 3, 4, 5, form an arithmetic sequence. Determine the value of K and P. So if the last 3 forms an arithmetic sequence, then we can use the idea of common difference. That means 3.8 minus P is the same as 4.3 minus 3.8. You should remember, sequence and series. And then you get P equals to 3,3. Then the other information was given the mean. It is given that the mean is 7,7. Now how do we find mean? You will remember you must add up all the testosterone values, divide by 5 because there's 5 athletes. And that should be 7,7. And then cross multiply, simplify, and K is equal to 9.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Welcome to Mathematics with Suleiman. I'm still discussing Gauteng Prelim 2025 Grade 12 paper, and today I'm doing question 3 on analytical geometry. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Gauteng Province, Preparatory Examination 2025, Paper 2, Question 3. Question 3. Now in the diagram, triangle ABO is drawn. E is the midpoint of AB, which is produced to C. A is the x-intercept, and C with coordinates 0 and 10 is the y-intercept of AC. Line EF is drawn parallel to the x-axis. AB is perpendicular to OB, and the angle of inclination of OB is 108,43 degrees. Now the angle formed by AC and the y-axis is called alpha. Please have a good look at that sketch. Make sure you understand exactly what is given, because that is going to help you to answer the question that follows. Start question 3.1. Determine the gradient of the line OB. Now see, where's the line OB? It lies on that angle of inclination of 108,43 degrees. Now you remember this will be then the 10, if you remember. So the gradient of OB, or the M of OB, is then the 10 of 108,43 degrees, which of course, if you use a calculator, is -3. Question 3.2. Determine the equation of the line AB in the form y equals to mx plus c. Look at AB. See what was given there? Remember, AB and OB are perpendicular, and you remember, if lines are perpendicular, the product of the gradients is -1. So if the gradient of OB is a -3, then the gradient of AB will be a +1/3. And of course, the y-intercept was given as 10. Therefore, the answer is y equals to 1/3 x plus 10. Or you can use the formula y minus y1 equals to 1/3 x minus x1. Remember, we do have point C, which is 0 and 10. So remember, there's always more than one way to solve a problem. Now, question 3.3, calculate the coordinates of point B. Now, if you look at point B, remember we already got the equation of line AB. It is a third x plus 10. Then the equation of OB is also easy to get. Remember, OB already have the gradient as -3, and it runs through 0, so its y-intercept is 0. So therefore, OB's equation is then y equals to -3x. So at B is where the two equations are equal, and now you can solve for x. And therefore, x is -3. Then how do you get the y value? Well, you just substitute x equals to -3 in any of the two equations, and you'll get a 9. So therefore, the coordinates of B is then -3 and 9. 3.4, calculate the length of BF. Now, have a quick look, where is BF? BF is part of triangle ABO. We have a look at the triangle ABO. Remember what was given? That E is the midpoint of AB and EF is parallel to AO. So this should remind you of a grade 10 theorem. Namely, line segment drawn from the midpoint of one side of a triangle parallel to the second side bisects the third side. So I hope you still remember that grade 10 one. So let's first, can we find the length of BO then? Yes, we're using the distance formula because we got coordinates of O, which is 0, 0, coordinates of B, we worked it out in the previous question. So then the length of BO is then 3 times the square root of 10. Remember what I said earlier? That EF bisects BO. So that means if BO is 3 times the square root of 10, then of course BF is a half of BO. So therefore it is 3 times square root of 10 divided by 2. And that should give you the final answer. Question 3.5, calculate the area of triangle CBO. Have a quick look, where is CBO? Remember the formula for area, half base times height. So we can use BC perhaps as the base and OB as a height, or it doesn't really matter. Remember, you multiply. Then of course BC we haven't got yet, but we can work out BC because we have point B, we have point C, using the distance formula, and it will be the square root of 10. OB we already have as 3 times the square root of 10. So therefore, using the calculator, and the answer is then 15 square units. Now at 3.6, we must determine the size of alpha. We have a quick look, where is alpha? Then we start by looking what's happening inside triangle OBC. Inside triangle OBC, angle COB. Have a quick look. COB. Remember that is 108,43. If I take away the 90 degree, which is angle COX, can you see that 90? Then we get angle COB as 18,43. So inside triangle BOC, we got now the 90 degree of angle B, we got the 18,43 of angle BOC, so I can get angle BCO. Angle BCO is then 180 degree minus the 90 and the 18,43. Remember, sum of the angles of a triangle. And that should give us then 71,57. So if angle BCO is 71,57, then alpha is the same value. Remember, vertically opposite angles.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Welcome to Mathematics with Suleiman. I'm currently discussing Gauteng Prelim 2025, paper of last year, grade 12, and this is now the question on analytical geometry. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Gauteng Province, Preparatory Examination 2025, Paper 2, Question 4. Question 4. In the diagram, point P, which is negative 3 and 4, is the center of the circle passing through points B and T, and of course the origin. A second circle is drawn with center Q, and its equation is given as x squared minus 12x plus y squared plus 12y plus 54 equals to 0. Points R and S, S3 and negative 9, lie on the circle. AS and AR are both tangents to the circle with center Q. B is the x-intercept of AS. Please have a good look at this diagram. Make sure you understand exactly what was given, and that will assist you in answering the questions that's going to follow. In 4.1, determine the equation of the circle with center P. So to do this, we make use of Pythagoras to find the radius. The r squared is, of course, the negative 3 squared plus 4 squared. And that gives you r squared as 25. Now, of course, negative 3 comes from x plus 3 squared. Positive 4 comes from y minus 4 squared. Then equals to 25. And that is the equation of the circle. In 4.2, OT is the diameter of the circle with center P. Determine the coordinates of T. Now, if OT is the diameter, it means it will go through point P. And that means then that point P is the midpoint of OT. So we're going to use the midpoint formula to find the coordinates of T. So let's start with the x value of P. Right. So remember now, the origin is 0, 0. So therefore, x0 plus xt over 2. Right. And of course, then you go, of course, the x of p is the negative 3. Cross multiply, and then you get x of t is negative 6. Do the same with the y coordinate. So the y of p is then y0, that also comes from the origin, plus yr over 2. Cross multiply, and then yt is 8. So therefore, the coordinates of t is then negative 6 and 8. In 4.3, calculate the coordinates of q. Unfortunately, the equation of that circle with center q was given to us. So we have to rewrite it in another form, and that will entail completing the square. So if you take x squared minus 12x first, then, of course, if you complete the square, remember the formula b over 2 all squared, then you'll get 36. So you add 36 on the left-hand side, but you must also add 36 on the right-hand side. Remember the law of equations. Then if I use the y squared plus 12y, I again complete the square there, and I'll get 36, which I again add to both sides. And then the 54 I'll carry over to the right-hand side. Then I get, if I take the first 3 terms, perfect square, so it will be x minus 6 squared, plus, if I take the y's, it will give me also a perfect square, y plus 6 all squared, And of course, on my right-hand side, if I add those three terms, I'll get an 18. So therefore, the x value of the q will be then 6 coming from x minus 6 and a negative 6 coming from y plus 6. And 4.4, determine the equation of AS in the form y equals to mx plus c. Now let's first start with the gradient of QS. So the m of QS, remember we got point Q, we got point S. Then we use change in y over change in x. That means minus 6 minus a negative 9 over 6 minus 3. So the gradient of QS is therefore negative, is then positive 1. But AS and QS, remember, are perpendicular. We've learned that in geometry, Euclidean geometry. So their product will be negative 1. So therefore, gradient of AS will be negative 1. Then we use the formula y minus y1 equals to m into x minus x1. So already we know now that m is 1. Then we use the point S as the y1 and the x1 values. Remove the brackets and simplify, and you get the equation of ASS, y equals to negative x minus 6. 4.5, identify the type of quadrilateral that ASQR is, and then of course substantiate your answer. ASQR. First of all, if you look at QS and QR, they form the radii of that circle Q. So therefore, those two sides are equal. Whether you can work it out or you don't have to, because they are equal. And then of course, AS and AR are also equal. Remember in Euclidean geometry, we've learned that tangent lines drawn from the same point to the same circle are equal. So there we have quadrilateral with two shorter consecutive sides equal and two longer consecutive sides equal. So therefore, this is the properties of a kite. So therefore, ASQR is a kite. Right, question 4.6. Determine the scale factor K by which the radius of the circle with center Q should be increased such that the two circles touch once. So we first need the radius of circle P. We know how to work it out. We have all the information there. So remember, it is the square root of 0 minus negative 3 squared plus 0 minus 4 squared. So that gives you the square root of 25. So therefore, the radius is 5. And can you see where does it fit into the formula? Then we also need to find the radius of Q, the circle Q. This, of course, 18. So r squared is equals to 18. Or you can say r is the square root of 18. Then, of course, the length of PQ is, of course, negative 3 minus 6 squared plus 4 plus 6 squared, which is the square root of 181. So that explains then the formula. PQ is RP plus K times RQ, where K is the scale factor. Then do your substitution as shown with the arrows. Simplify, and you get K equals to 1,99.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Welcome to Mathematics with Suleiman. I'm currently discussing Gauteng's Prelim paper of 2025, and today I'm doing trigonometry, which will be question 5. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Gauteng Province Preparatory Examination 2025, Paper 2, Question 5. Question 5.1. given is the sine of beta is equal to 12 over 13. And let me emphasize, positive 12 over 13. And where tan of beta is less than 0. So what does that mean? It means negative. So two important things. Sine of beta is positive 12 over 13. Tan of beta is less than 0, negative. So those two given things are very important because it is going to guide you in determining where to place your diagram. So with the aid of a diagram and without the use of a calculator, determine the value of the sine of 2 beta. Now be careful, people. If they say without a calculator, that means the answers cannot be presented as a decimal. So that you must remember. So let's decide where are we going to place our diagram. So first of all, where is sine positive? First and second quadrant. Where is tan negative? Second and fourth. So where do we have the two that coincide? It is in the second quadrant. Why do I choose second quadrant? Because that is where sine is positive and where tan is negative. Then, of course, sine is defined as opposite over hypotenuse. So 12 over 13, look at the diagram. 12 over 13. And of course, you can find the other side by using Pythagoras. And you get x negative 5. Now the drawing is completed. Now we can answer the question. The sine of 2 beta. Now what is 2 beta? It is a double angle. So you need to go and check your identity on double angles. Sine of 2 beta is 2 sine beta cos beta. So sine beta from the drawing is 12 over 13. Cos beta from the drawing is negative 5 over 13. Then, of course, multiply the numerators, multiply the denominators. Of course, you can use a calculator here. Just be careful. Do not have any decimal values. So, therefore, the answer is then negative 120 over 169. Question 5.2. Given that the cos of alpha minus theta is equal to the cos of alpha cos of theta plus sine of alpha sine of theta, and of course we should recognize our compound angles. Now we have to use the given compound identity to prove that sine of alpha minus theta is sine of alpha cos of theta minus cos alpha sine theta. Now can you see cos is given, we must deduce sine. So immediately you must put the two together. Sine and cos are co-functions, and co-functions involve 90 degrees. So remember that now. So sine of alpha minus theta is the same as the cos of 90 minus alpha minus theta. Remove the brackets inside the square bracket, right? And then, of course, we can rearrange the terms, and even the positive theta can be replaced by a negative theta by taking out a negative. Right? Now we have it as sine of alpha minus theta. And now we can expand it the way we were given by the cos of alpha minus theta. Again, go back to cos of alpha minus theta. It is cos theta, cos alpha, cos theta, plus sine alpha, sine theta. Then expand this one the same way, and you should get the same answer. Or, alternatively, you can again do the same thing, 90 minus alpha minus theta, right? Remove the brackets, rearrange the terms. Now I have theta instead of alpha inside the bracket now. Then again, expand it the way cos alpha minus theta was given, right? Then again, cos of 90 plus theta is minus the sine of theta. This is a tricky one. This one we always get wrong. Cos of 90 plus theta. You expect it to be positive, but now this is the one which is negative sine theta. So please be careful. Then, of course, the sine of 90 plus theta is the cos of theta. And then, of course, you can rearrange so you can have it as sine alpha cos theta minus cos alpha sine theta. To be able to master this deduction or proof, you need to go practice. Question 5.22, hence or otherwise, evaluate sine of 76 degrees times the sine of 44 minus sine of 14 times the sine of 46. Now, I know they didn't say without a calculator. Maybe they should have said without a calculator, but use the word hence to guide you. That means they sort of ask you to use what you determined in the previous question. So remember now in the previous question we've established that the sine of alpha minus theta is equal to sine alpha cos theta minus cos alpha sine theta. So we're going to use that to guide us. So let's do that. So sine 76 times sine of 44 minus sine 40 times sine 46. So what I'm going to do is I'm going to leave sine 76 as is and then change sine 44 to the cos of 46. Now, where is it coming from? Well, sine of 44 is the cos of 90 minus 44, which gives you the cos of 46. Do the same with the sine of 14. Replace sine with cos by subtracting 14 from 90, and you get cos of 76. Sine of 46 can remain like that. Remember, the idea is to have the same angles throughout. Remember, you must have the same alpha and you must have the same theta. Now alpha is 76 and theta is 46. It wasn't like that originally. Remember, so the problems were 44 and 14. So I had to change that to suit the identity. I hope it is clear now. Then do the reverse of the compound angle, so you can write it back as sine of 76 minus 46. It gives you the sine of 30, which of course is a half. Or alternatively, you can do the same, but this time you can change 76 to the cos of 40, also subtracting it from 90. And of course, you can also replace sine of 44 with cos of 46 by subtracting it from 90. Either way, it doesn't matter. You'll get now 14 plus 46, which is a cos of 60, which is also a half. Question 5.3. In this example, you'll see a combination of gradient formula in calculus with compound formula in trigonometry. Quite interesting. So given is that the f of x equals to the sine of x. Now you must show that the f of x plus h minus the f of x over h, which of course is the gradient formula in calculus, can be written as sine x into cos h minus 1 over h plus cos x into sine h over h, which of course is a compound identity. So where do we start? Remember, given was the f of x is sine of x. But in the compound formula, we also need x of h. So therefore, the f of x plus h is then the sine of x plus h. So once we've established that, then look at sine of x plus h. Isn't that a compound identity? So let's expand it the way you know it. Sine x cos h plus cos x sine h. Once you've done that, then we're going to use now the gradient formula and substitute into the gradient formula. Then you end up with sine x cos h plus cos x sine h minus the sine of x. Then I'll take that last two and just switch the two so that I can have it as sine x cos h minus sine x plus cos x plus sine h. Just rearrange the terms a little bit. Then I can take out sine x as a common factor. Because remember, I'm looking for a cos h minus 1. Don't forget. That's why I'm doing it. Then I have sine of x into cos h minus 1 plus cos x sine h over h. Then I'm going to split the two. Remember the inverse of LCM. When you add fractions, you find the LCM h. Now I'm going to reverse that. So the h will be divided back into sine x into cos h minus 1 and also into cos x sine h. So I split the two with a plus in the middle, and then I get what I was supposed to prove, that the sine of x into cos h minus 1 over h plus cos x into sin h over h. Or 5.3 got an alternate solution. So what we can do is if we take again the gradient formula, f of x plus h minus the f of x over h, then we replace the f of x with the sine of x, and of course the f of x plus h with the sine of x plus h. So that can also be done, right? Then we expand sine of x plus h, expand that one, and then of course again rearrange the terms to have it as sine x cos h minus sine x plus cos x sine h. Rearrange. So I can again take out sine x as a common factor to get cos h minus 1. Once I've done that, then again split the two fractions, divide h into sine x into cos h minus 1, and also divide h into cos x sine h. Then we get again what we're supposed to have to prove.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Welcome to Mathematics with Suleiman, and this is the Gauteng Prelim paper of 2025, and this is going to be trigonometry. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Gauteng Province, Preparatory Examination 2025, Paper 2, Question 6. Question 6.1. Simplify the following to a single trig term without the use of a calculator. The tan of 180 minus x times the cos of 180 minus x times the cos of 240 into tan squared y minus 1 over cos squared y. Now here you must always remember the so-called golden rule. Try to replace tan with sine and or cos, if that is possible, and also apply your knowledge of the reduction formula. But remember now the four quadrants, when is which one negative and when is which one positive in the four quadrants. So that is very important. So let's start with the tan of 180 minus x. That is in the second quadrant where tan is negative. So it is, so tan of 180 minus x can be replaced by minus 10x. Then the next one, cos of 180 minus x, is also in the second quadrant. Cos is also negative there. So therefore, we can replace cos of 180 minus x with minus the cos of x. Let's go down to the denominator now. Now the cos of 240 can be replaced by 60, because 180 plus 60 gives you 240. So that is third quadrant where cos is negative, so minus cos 60, and in the next step it becomes minus a half. Then sine squared y over cos squared y can replace tan squared y. Then of course we can now add those two terms within the bracket by using the LCM, cos squared y. Then at the bottom we get then sine squared y minus 1. You can take out the negative, we get 1 minus sine squared y, which can be replaced by minus cos squared y. Then it becomes from sine squared plus cos squared equals to 1. Don't forget that identity. Then on top, the cos will cancel and only left with positive sine x, because it's a negative times a negative. At the bottom, of course, I have now cos squared y over cos squared y, which in its own will become negative 1. So at the bottom, I got negative a half times negative 1, which is now positive a half. So now I got sine x divided by positive a half, which becomes 2 sine x. Question 6.2, prove the identity. Sine of 3x divided by sine x cos x is equal to 4 cos squared x minus 1 over the cos of x. Now please remember, when you have to prove an identity, you can either only work with the left-hand side on its own, and then again with the right-hand side if necessary. But you need to deal with the two sides separately until they look the same. In our example, we can choose the left-hand side, because if I look at sine 3x, I can see I can change that into sine of 2x plus x. And of course, automatically there becomes a compound angle for sine. So we can expand it as sine 2x cos x plus cos 2x sine x over sine x cos x. Then the sine of 2x is a double angle, so I can replace it with the identity 2 sine x cos x. And the same with the cos of 2x, I can also replace with the identity 2 cos squared x minus 1. Right. The next step, I can now remove the brackets, collect the like terms, and then I can take out sine x as a common factor, and I'm left with 4 cos squared x minus 1 over sine x cos x. Then sine x can cancel, and I'm left with 4 cos squared x minus 1 over cos x, which is exactly the same as my right-hand side. 6.3, determine the general solution of cos x plus 1 equals to sine of x. Now remember, the whole idea of trig equations is that you can only have either sine or cos or tan, but you can't have two of them in one equation. So here I must either replace cos with sine or sine with cos, but there's no link yet. However, if I maybe try quadratic identities, that might work. So if I square both sides, I get cos squared x plus 2 cos x plus 1 equals to sine squared x. And now we recognize sine squared x. It comes from 1 minus cos squared x, isn't it? Do you remember the identity sine squared x plus cos squared x equals to 1? Yes. Then you take all the terms to the left-hand side, factorize, and you get that cos x is 0 or cos x is negative 1. Let's first look at cos x 0. Now, if you take your calculator and you do the shift cos of 0, then you'll get 90 degrees. So your reference angle will be 90. However, the cos of 270 is also 0, but we are not going to use that. We're only using 90 degrees. Don't forget that. Because if you deal with 270, then sine becomes cosine, and we don't want that. So therefore, if the reference angle is 90, then our answer is therefore x equals to 90 degrees plus k times 360, and k an element of the integers. Or if I take the cos x equals to negative 1, and I do the same thing here, shift cos of a 1, you'll get the reference angle as 0. And of course, you can check it on your calculator that the cos of 180 will give you negative 1. So therefore, we must use 180. So therefore, x is then 180 plus k times 360, and k an element of the integers.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Time to Mathematics with Suleiman. I'm going to continue with the Gauteng Prelim paper of 2025, paper 2, and in this video I'm doing the trigonometric graphs. Gauteng Province, Preparatory Examination 2025, paper 2, question 7. Question 7. In the diagram below, the graph of the f of x equals to negative cos 2x is drawn, and the interval is negative 180 to positive 180. Have a good look at the given function as well as the sketch, because there's two things you must take note of. First of all, it is minus the cos, so you expect the opposite of the cos graph with a positive. right? And of course, secondly, it is a cos of 2x, not 1x. So we also expect something to happen here. Of course, if it's 2x, the graph should shrink half its original size. Right, question 7.1. Write down the period of f. Now be careful now. By period, we don't mean interval, so don't confuse the two. Interval is what you see physically, but period depends on what value is in front of the x. If there was a cos of 1x, then the period would have been 360. But it's a cos of 2x, so it's exactly half. So therefore, a half of 360 is 180. And 7.2, what is the range of f? Well, the range, of course, is a y value, so the graph lies between -1 and +1. So there are two ways of presenting the answer. You could either use square brackets or you can use the inequality signs. 7.3, on the grid provided, draw the graph of the g of x equals to the tan of x minus 45 for the interval -180 to +180. Clearly show the asymptotes and intercept with the x-axis. Now be careful now. What does x minus 45 mean? It means that the tan graph will shift 45 degrees to the right. It's always with the opposite sign. If it's -45, it moves to the right. If it's +45, it will move to the left. So let's start with the asymptote. Let's start with the 90-degree asymptote. Usually, tan of x, the asymptote is 90. But if it moves 45 more to the right, then it will be 90 plus 45. So therefore, that asymptote is then 135 degrees. The same on the negative side. It would have been -90 if it was tan of x. But now 90 moves 45 to the right. So -90 and 45 to the right will give you then -45. So there you are. That explains the two asymptotes, the one of -45 and the one of 135. And of course, all the other points will move 45 degrees to the right. So please make sure you show all those intercepts. Don't forget. Question 7.4, for which values of x is the f of x less than or equal to the g of x? And you must only look at the interval -180 to 0. Don't look on the positive side, only look on the negative side. Now, what do we mean by the f of x less than the g of x? That is where the f graph physically lies below the g graph. If you look at my red lines, then you will see exactly where that is. So the first one will be between -180 and -135, and the second answer will be between -90 and -45. Right, question 7.5, what is the maximum value of the h of x equals to 4 to the power 2 sine squared x minus 1 for x all real values? We have to be a bit creative here. So if you look at the exponent 2 sine squared x minus 1, if you take out a negative, you get 1 minus 2 sine squared x in the bracket, which of course represents the cos of a double angle. So therefore we can replace the exponent with minus cos of 2x. And that of course is the cos graph. So the exponent for the maximum, look at the graph, the maximum value will be 1. So therefore it will be 4 to the power 1. Because minus cos 2x must be 1. Then it's the maximum. So therefore, 4.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.
Welcome to Mathematics with Suleiman. I'm currently discussing Gauteng Province Prelim Examination 2025. And this question is going to be based on solving of 3D objects in trigonometry. So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming. Gauteng Province Preparatory Examination 2025, Paper 2, Question 8. Question 8. In the diagram below, which is a three-dimensional diagram, A, B, and C lie in the same horizontal plane. The vertical pole DC is H units and AB is K units. Angle CAB is theta and angle BAD is beta. And of course, angle DBA is alpha. So please make sure that you orientate yourself in a 3D format. Otherwise, you're going to have a challenge in answering the questions. Question 8.1. Determine the size of angle CDA in terms of theta. Now be very careful, people. CDA. You must look for that angle in triangle DAC. See, I've tried to color it in red. That is a triangle at the back. So don't get confused now. So angle CDA, remember the angle C of that triangle is 90. The angle A of the triangle is theta. So sum of the angles of a triangle, then CDA got to be 90 minus theta. Then 8.2, determine the length of AB in terms of H and theta. Now look where is H, look where is theta, and look where is AD. It's still part of that very same triangle at the back. So let's use that triangle involving H and involving theta. If you look at that triangle which is right angular, then you will realize that the sine of theta is opposite over hypotenuse. So therefore it is H over AD. Cross multiply and make AD the subject. So therefore AD is then H over the sine of theta. Or you can use the other angle cos of 90 minus theta and you'll get exactly the same answer. Question 8.3. Show that CD, have a look, where is CD? Prove that CD can be written as the H equals to K times sine alpha times sine theta over the sine of alpha plus beta. Now look in triangle ABD, the one I've colored in red. That you see where's triangle ABD? Now in that triangle, angle BDA is then 180 minus alpha plus beta. Remember, the two bottom angles are alpha and beta. Sum of the angles of a triangle. Then we're going to use the sine rule in the same triangle. So AD over the sine of DBA is equal to AB over the sine of BDA. Remember the sine rule. Sine of DBA is the sine of alpha, and of course BDA is the sine of 180 minus alpha plus beta. And of course the sine of 180 minus alpha plus beta is the same as the sine of alpha plus beta. So that is now AD. But from the previous question, we also know that AD is H over sine theta. So therefore, we can equate the two now. K sine alpha over sine alpha plus beta equals to H over sine of theta. Now we can cross multiply and make H the subject. So therefore, CD is then H, which is H, is K times sine of alpha sine of theta over the sine of alpha plus beta. Question 8.4. Calculate the length of the vertical pole, which is known as CD, to the nearest meter if K is 95 meters, theta is 43.9 degrees, beta is 61 degrees, and alpha is 32.7. So now we already know the formula from the previous question. So therefore we just do straight substitution. And of course the rest is calculator work. Remember the nearest meter. So 35.66 becomes 36 meters.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos. Welcome to Mathematics with Suleiman. I'm still discussing the Gauteng Prelim paper of 2025, and in this question I'm going to look at Euclidean geometry. Gauteng Province Preparatory Examination 2025, paper 2, question 9. In the diagram below, CD is the diameter of the circle with center O. E is a point on the circle such that DE is produced to G. OE, OG, CE, and CG are drawn. So let angle OEC be X and angle COG be 90 degrees. Please have a good look at the drawing, fill in what is given, and then take it from there. Right, question 9.1. Prove that OCGE is a cyclic quad. I've demarcated OCGE in red. Now always remember, when is a quad a cyclic quad? There are different situations. Let's see which one is applicable here. O1 is 90 degrees, as we all can see. Angle CED is also 90. That's angle in a semicircle. Therefore, CEG is 90 because they are adjacent angles, or you can say angles on a straight line. So therefore, O1 equals to angle CEG, and that makes OCGE a cyclic quad. Why? Because they have equal inscribed angles subtended by the same chord CG. 9.2, name with reasons 3 other angles equal to x, and in my animation I will show that. So G1 equals to E2, that is x, reason angles in the same segment. C1 equals to E2, also x, angles opposite equal sides, or the radii are equal. And then G2 equals to C1 is also x, angles in the same segment. Question 9.3, determine the size of angle DOE in terms of x. If you look at DOE as shown with the red lines, then DOE is the central angle, and then DCE is the angle in the opposite segment. And we know the theorem that central angle is twice the inscribed angle. So therefore O3 is twice x. Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos. Welcome to Mathematics with Suleiman. I'm still discussing the Gauteng Prelim paper of 2025, and in this question I'm going to look at Euclidean geometry.
So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming.
Once Preparatory Examination 2025, Paper 2, Question 10. In the diagram below, triangle ABC and DF are drawn with angle A equals to angle D, angle B equals to angle E, and angle C equals to angle F. Now you must use the diagram above to prove the theorem that states that if two triangles are equiangular, then their corresponding sides are in the same proportion. That is, that DE over AB is equal to DF over AC.
So if you look at the diagram and 10.1, now on AB, you mark of AP equals to DE. So AP is equal to D, so that will be P there. So that AP and DE are equal. And you also mark off Q there, so that DAQ equals to DF. So that those sides are equal. Right. So in triangle APQ, which is this triangle, so I need to complete this drawing there. So in triangle APQ, which is this one here, and triangle DEF, so in those two triangles, we have angle A equals to angle D, that is given. We have AP equals to DE, that is our construction. And we have AQ equals to DF, also construction. So therefore, those two triangles are then congruent, because the reason is side, angle, side. Now, if they are congruent, that means that this angle APQ here is equal to angle E, right? So I can also put a circle there. And of course, angle E, right? So an angle E is equal to angle B, like that we know from the given. So therefore, angle APQ is equal to angle B. So therefore, those two angles are equal. And people, if they are equal, then that means these two lines will be parallel, because we have equal corresponding angles. So therefore, AP over PB, so AP over PB is equal to AQ over QC. Right, so that we know from our previous theorems, because those two lines are parallel. But AP and DE are equal. Right, and AQ and DF are equal. So therefore, we can say, therefore, that DE over AB is equal to, so DE over AB is equal to DF over AC. 10.2, in the diagram below, A, C, and F are points on a semicircle with center B. A circle with center C is drawn. Now the radius of the semicircle is twice the radius of circle C. FED is a tangent to both circles at F and E respectively. ABCD is a straight line. Please have a look at this diagram and make sure that you can see exactly what you can recognize. And by that I mean what theorems can you recognize, and even possibly which angles are most probably the same. Right, so 10.2.1, you must prove that triangle AFC, which is this triangle here, is similar to this triangle here, triangle FEC. Now, when are triangles similar? They are similar if they are equiangular. So let's start with angle A. Now, angle A, of course, is equal to angle F3. A equals to F3. Remember, this is the tangent line, and that is the chord. So it's angle between the tan and the chord. Then secondly, angle F2 is 90 degrees. Remember, angle in a semicircle. And of course, angle E1 is also 90 degrees. Again, tangent and radius. Angle between the tangent and the radius. So therefore, angle F2 and E1 are equal then, because they both 90. And then thirdly, angle C1 is equal to angle C2. Right? And we can get it by using sum of the angles of a triangle. So there we have three sets of angles equal. So therefore, triangle AFC is similar to triangle FEC. Angle, angle, angle. Question 10.22. Now, if the radius of the smaller circle is P, determine the following in terms of P. The length of FC. Now, you can see there is FC. You must find the length of FC in terms of P. Now, remember, given was that the radius of a semicircle is 2 times the radius of the circle C. So, now remember now. So, therefore, if the radius of a smaller circle is P,
then therefore AC will be 4P. That is 2P plus 2P. So there you are. So that is what we have here. So remember that we already proven that those two triangles are similar. So now we can say FC over EC is equal to AC over FC. Because remember, we did prove that they are similar. So if they're similar, then we can cross multiply, and then we get FC squared equals to AC times EC. And remember, AC is 4P and EC is 1P. So therefore, FC is then the square root of 4P squared. So therefore, FC equals to 2P. Question 10.22. Again, if the radius of the smaller circle is P, determine the following in terms of P. Number B now, the length of FD. So there's F, and so that is FD. If it's given that EF and ED are equal. Right, so that is given. Now remember now that this is P from the previous question, and of course that is 2P. So inside this triangle, I can use Pythagoras by saying that FE squared is EC squared minus EC squared. FC squared minus EC squared. That gives you then 2P squared minus P squared, which is then, of course, square root of 3 times P if you simplify. So therefore, FD is then twice square root 3 times P.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos. Welcome to Mathematics with Suleiman. I'm still discussing the Gauteng Prelim paper of 2025, and in this question I'm going to look at Euclidean geometry.
So please, very important to subscribe to my channel so that it can enable me to do some more videos. So please, people, don't only watch my videos, also subscribe to my channel, and then you'll be able to see more of my new videos coming.
Gauteng Province Preparatory Examination 2025, Paper 2, Question 11. And yes, this is the last question in this particular Paper 2. In the diagram below, cyclic quadrilateral EFGH is drawn. Chords EH and FG are produced to meet at K. M is a point on EF such that MK is parallel to EK. KG equals to EF. Please have a good look at this drawing, see what is given, and try to visualize what deductions can be made before you look at the questions.
At question 11.11. Now in this question, we need to prove that EF squared is equal to KE times GH. Now how do we know which triangles to choose to be able to prove that? And of course, this is based on similarity. So therefore, I need to choose triangles where these sides appear. Now, if you look at triangle KGH, this one here, and the big one KFE, then you will pick up those values in there. Right? You will pick it up in there. All those values, EF, KE, and GH will appear there. Also, don't forget that KG and EF are equal. So they don't have to appear there. You can just replace them. So that's why I chose those two triangles. And I'm first going to prove them similar. Now, they are similar because angle K is common for both. Then angle H1 is equal to angle F, exterior angle of a cyclic quad. And then, of course, we have G1 equals to angle E. And, of course, so we can use sum of the angles of a triangle to prove that. So, therefore, the two triangles are similar. angle, angle, angle. And the fact that they are similar, we can of course now say that kg over kf, ke I mean, is equal to hg over fe. I choose those values because I want to prove this, don't forget. Then I cross multiply, right? And then of course I can replace kg with ef. And that's how I get ef squared equals to ke times ge. Right, question 11.12. Now we must prove that kg squared is equal to em times kf. Now, again, it can be a bit difficult, but the easy way is, people, to look where do you see kg, where do you see em, where do you see kf. And also don't forget that kg and ef are equal. Now, you remember given was that line, ke, and this line GM are parallel. So they are parallel. So if I say EF over EM is the same as KF over KG. Let me repeat. EF over EM equals to KF over KG. Then that will help me a lot. Why can I say that? Because remember, those two lines are parallel. Then we cross multiply, and then we get EF times KG equals to EM times KF. But don't forget that KG and EF are equal. So therefore, KG squared equals to EM times KF. Now, 11.2. If it is given that KE is 20, KE is 20 units, KF is 16 units, right? And of course, GH is 4 units. Calculate the length of EM. Now, it looks a bit difficult, but what we must do is we must just see what was already proven, and you'll see that we already proved that EF squared is KE times GH, and that KG squared is EM times KF. Why do I choose them? Because that is where all the given values are. And of course, the EM we are looking for. So if we have already proven that, then what we do is we just take EF and KH and we square both sides. Then we can replace EF squared with EM times KF, and we replace KG squared with KE times GH. Then we cross multiply and we make EM the subject. Then we do the necessary substitution. Then we get the answer is 5 units.
Thank you for watching Mathematics with Suleiman. Please don't forget to share, like, and subscribe. Remember, subscription is free, and with your subscription, it can help me and encourage me to do more videos.